Energy dependency is becoming more of a concern for politicians. In Europe, they realized how dependent they were on Russian gas after Mr. Putin reduced the gas supply to the Ukraine a few years ago. Dependency on oil coming from the unstable Middle East is another concern. A universal fuel produced from any other energy carrier, fossil, nuclear or renewable, would help. This is hydrogen. Use of less primary energy by improved energy efficiency would also help. PEM fuel cells will do the job. Hydrogen and fuel cells will help reduce energy dependency. Although the efficiency of individual parts in the conversion chain are important, what really counts is the total energy chain efficiency, measured from well to wheel. If we compare the well-to-wheel efficiency of the technologies available, both now and in the future, we see large differences. A conventional car with an internal combustion engine that is used according to the standardized new European drive cycle loses 83% of the energy originally available that is present in the crude oil coming from the well. These losses and energy used during drilling, transportation and refining, and during conversion of the gasoline inside the internal combustion engine, a 17% well-to-wheel chain efficiency is the result. A car with an electric engine charged by battery only is much more efficient. In this well-to-wheel chain, only 75% of the original energy in the fossil fuel is lost. There are losses in mining and transportation, but the main loss is the conversion to electrical energy in the power plant. In Europe, the average generation and distribution loss is over 67%. At the power plug, only 33% of the original heating value is left. If the electric vehicle is charged from the plug, there are additional losses of approximately 8%, leaving the battery car with a total chain efficiency of only 25%. By building a fuel cell car with batteries, a so-called fuel cell and battery hybrid, efficiency can be improved further to between 30 and 34%, depending on the system technology. The well-to-wheel losses are, in this case, mainly in the hydrogen production and hydrogen compression, and are coming from conversion losses in the fuel cell system. All these losses result in a maximum well-to-wheel efficiency today of 34%. This is very good compared to the original internal combustion engine. But efficiency can be improved even further by using the hydrogen decompression technology developed by HyET. To store sufficient energy on board the car, automotive companies have decided to use compressed hydrogen at 700 bar. Until now, the compression energy needed to compress the hydrogen up to this pressure level could not be regained and was lost. With the HyET hydrogen decompression system, most of this energy can be recovered, increasing well-to-wheel efficiency to 40%, an improvement of 6%. To the best of our knowledge, fuel cell hybrid cars, when using the HyET decompression system, are the most efficient of all vehicle propulsion technologies. In the PEM fuel cell, hydrogen is converted at the anode into protons and electrons. The protons travel through the proton conductive membrane to the cathode, while the electrons travel via an external electrical circuit to the cathode as well. At the cathode of the PEM fuel cell, air is supplied. Oxygen from this air is ionized in the cathode at the catalytic sites and reacted with protons and electrons. The result of this reaction is electrical energy, heat, and pure water. Cell voltage of this reaction is typically 0.7 volts per cell at a density of 10,000 to 15,000 amperes per square meter, resulting in a power density of up to 10 kilowatts per square meter. Molecular hydrogen at the high pressure side of the membrane is efficiently converted at the anode into protons and electrons. The efficiency of this hydrogen ionization approaches 100%. The protons travel through the HyET dry conducting membrane from the anode side to the cathode side, while at the same time the electrons formed travel through an external circuit to the cathode. In the cathode, protons and electrons associate and form molecular hydrogen again. The efficiency of this association process is almost 100%. This process has a cell voltage in operation of approximately 0.07 volts per cell and a current density of 10,000 to 15,000 amperes per square metre, resulting in a power density of up to 1 kilowatt per square metre.